2017 Paper 1, Question 6, Integration. So in this question here, we're given the graph of the function g of x is equal to e to the power of x, and we're given our values between 0 and 1. The diagram is shown for this graph, and we have to draw on the same diagram the graph of h of x, which is equal to e to the minus x, also in the domain of 0 to 1. So if we create our table and we look at our points, we're going to plot our points between 0 and 1, and we can see from the graph drawn first that it's in increments of 0.2. So that means we're going to sub in wherever there's an x, our value is 0, 0.2, 0.4, 0.6, 0.8, and 1. And of course it's e to the power of minus x. So if we sub those into our calculator, then we end up with 1, 0.82, 0.67, 0.55, 0.45, and 0.37. So that means our coordinates are out to 0 up to 1, out to 0.2 and up to 0.82, out to 0.4 and up to 0.67, out to 0.6 and up to 0.55, out to 0.8 and up to 0.45, out to 1 and up to 0.37. So let's plot those points on our graph. So we can see that this is a decreasing curve. So our curve is decreasing down. So we were getting 15 marks. And it's a 15C question, so our marks are broken down into 0, 5, 10, and 15. So B says then find the area enclosed by these two functions g of x and h of x, where the red line is h of x, and the line x equals 0.75. So the line x equals 0.75 is parallel to the y-axis, passing through the 0.75, which is here. So in other words, the area enclosed is this yellow shaded area. So therefore, what we're going to do is get the area under g of x using integration and the area under h of x using integration, and then we will subtract the two, and that will give us the area enclosed by the two. So in other words, the yellow area here that I'm shading. Okay, so in order to do that, we need to look at our limits. So clearly the limits are going to be 0.75 and 0. So if we set that up, we have to give our answer correct to 4 decimal places. So we say the area enclosed, or shaded, is equal to the area of g of x minus the area of h of x, and that will be within the limits of 0.75 and 0. So I'm going to call that area 1 and area 2. So I'll get area 1 first. So we say the area is equal to so we're going to be integrating e to the x with respect to x, and our limits will be 0.75 and 0. So therefore, if I integrate e to the x, I just get e to the x, and then I need to sub in my value of 0.75 and 0. So it's always upper limit minus lower limit, and e to the power of 0 is equal to 1. So that means area 1 is going to be e to the power of 0.75 minus 1. And I'm going to keep my answer like that for the moment because I want to round at the end rather than rounding twice. So area 2 is going to be our function h of x, which is e to the minus x dx. So if I integrate e to the minus x, well, I get e to the minus x, but I must divide by the derivative of the function minus x, which is minus 1. And then again, subbing in my limits of 0.75 and 0. Now, e to the minus x can be written as 1 over e to the x. And then if I divide that by minus 1, well, that's just minus 1 over e to the x. So now if I sub in for my limits, 0.75, and subtract from my lower limit. So again, e to the 0 is 1. So therefore, the area 2 is minus 1 over e to the power of 0.75 minus minus 1, which is just plus 1. Okay, so now what we're going to do is we're going to subtract area 1 from area 2. So we say area enclosed is equal to area 1 minus area 2, which is e to the power of 0.75 minus 1 minus minus 1 over e to the power of 0.75 plus 1. So if I get rid of my brackets, and then I can put into my calculator now so that I am only rounding at the last minute. So correct to 4 decimal places, we have 0.5894, and its area, so it's going to be square units. So that's going to be 10 marks, and it was broken down into 0, 5, 8, and 10. And again, I'm going to star that because we had to give our answer correct to 4 decimal places. So we would lose a mark if we hadn't got it in the correct format.